If you're watching this video on YouTube, you can watch on 1.5x speed.
Hello everyone, this is Expert Funda and you're watching on YouTube. So let's go to see to the question that we have 2360, and this is the longest cycle in a graph, right? So let's read the question. You are given a directed graph and we have n nodes numbers from 0 to n-1, and where each node has at most one outgoing edge. Okay, means that if there is any node, right, so this node is A and it should go to any other node. Let's suppose it is should go to B or somewhere any other nodes, right? So this is the meaning. Now it is saying that the graph is represented with you can say 0 index array, and it is called edges of n, and means size of edge should be n, so indicating that there is a directed edge, right, and which is from node I to node of edge I, right? What does this mean? I'll tell you. Just wait a minute. If there is no outgoing edge, right, means from node I to the edges, it will give -1. Okay, so what we have to do, we have to return longest cycle in the you can say in the graph, and if there is no cycle, we'll return -1. So a graph, a cycle is a path that starts and ends at the same node. Okay, so first of all, let me clean this one, right? So okay, now understand example 1, right? So in example 1, what we have given, edges we have given. Edges we have given is what? Let's suppose we have given this edges is 3, you can say 3, 4, 2 and 3. Okay, this is the graph this is the edge we have given. So I'll put into array to really represent this one. Okay, so first we have this one, this one, this one, this one. Okay, so if we'll talk about the edge I, so edge I is nothing but our, you can say, index or you can say node. So this index is nothing but our node. Okay, so for this one, this is index is nothing but it will become what? 0. So 0, 1, 2, 3, 4. Is it correct? Yeah, is it correct? Because what we have given, total nodes we have given n-1 means 5 node we have given, so it will go to 0 to 4. Now think this is the node or you can say index, we have index of the node, right? So this node is nothing but our 0. So if we'll talk about 0, right, so 0 is going to where? It is going to 3. So 0 will go to 3. Okay, now node 1 will go to where? It will go to 3. So this is 0 index. Now we'll take node 1, right? Let's suppose I'll take the node 1 here. So it will go to where? It will go to 3. Now similarly we have what? 2 we have, right? So if we'll take 2 here, right, so 2 will go to where? It will go to 4. So I'll take 4 somewhere here. Okay, so it will go to here, like it is, we have to make the direction also. Okay, like this we will go. Okay, now what we have, now we have 3 we have, right? 3 will go to where? 2. So I'll take, this is 3 and this is 2, so we'll mark like this. Now what we have? 4 we have, so 4 will go to where? 3, right, as you can see. So based on this given statement, I have prepared this one. As you can see, this is look like exactly that we have given in this example, correct? This one. So if we'll talk about this one, so you can see how our cycle is. Our cycle is 2 is going to 4, right? Then 4 is going to where? 3, and 3 is going to where? 2. See, we are going to 4 to 3, 3 to 2, and 2 to 4, and this is our longest cycle we have of 3 nodes. So 1, 2, 3, and that's why we will return output as 3. I think you have understood. If not, let's understand example 2. So in the example 2, similarly we have given what? Edges we have given 2, -1, 3 and 1. So if I re-represent these edges into an array, it will look like this one. Okay, so this is nothing but our edges, right? Now I will make all the nodes nodes you can say, or indexes from 0, 1, 2, 3, right? So total how many nodes we have? 4 nodes we have, and we have number from 0 to n-1 means 4 minus 1 is 3. Now I will say we have our node 0, right? So this node 0 is going to where? It's going to 2, right? So I will map this like this one, and we'll say this direction. Okay, now 1 is going to where? So this is done. Now we'll say 1 is going to where? -1. So we means we don't have direction for 1. So if we'll take 1 like here, right? So there is no direction for 1, right? Because this is -1, right? It is saying -1. If edges at I, right, like here, if have -1 means there is no direction, right? Now think about next node, that is we have 2, right? So we have 2 already here, right? So 2 is going to 3. So what we'll do, I'll put 3 somewhere here, okay? And 2 is going to map like this one, okay? This is the direction. Now only one left is 3. Now 3 is going to what? 1, okay? Like this. So we have completed all this one. And if you'll see this graph, right, this graph that we have made, this is look like this one, right? I think you have understood, right? Because see, in this graph you can say what happened. Give me 1 second. Yeah, so given graph, right, this one is having no cycle, right? And that's why we should say that we should return -1 as an output, right? If there is no cycle, we should return this one. If have cycle, we will count all the nodes and we will return, right? Now constant we have given is edges at I is what we have given. Edges at edge of length is should be what? Equal to n at least, and n should be greater than equal to 2 and less than 10 to the power 5. Edges at I should be equal to -1. It should be greater than -1, or it should be less than n. And edges at I should not be equal to I, right? Means node should not be have its value. There is it should not be itself direction. Okay. Now if we'll talk about the approaches, right? So there is multiple approaches. You can use either DFS, or there is another approach that is you can say Kahan's algorithm, right? That you can also use, right? So first I will go with the DFS search. If you like to create the video on the Kahan's algorithm, I will do the same. Okay. So let's understand about the DFS, right? So what we will do, right? So for the depth first search, right, what we are doing, we will take one node and we will traverse to its children node like this, right? And we will do the backtracking. We'll come to some node and we'll check its other nodes, right? Like this. We will backtrack again and we'll check its other node, right? So that for each node you can say has more than one outgoing edges, right? So what we will do, we'll see what kind of the graph we can create for this, right? And better let's understand or consider that a node we have, right, which belongs to a cycle, right? And it would simply that the only outgoing edges of the node would also be in the cycle. Okay, so as a result, node cannot be a part of any other cycle because it has only one outgoing edge. Means I'm trying to say, so let's consider an example in which we will take a node, right? So if there is a node, right? So if this node is belongs to any cycle, right? Any cycle, and means there is a cycle, means this node having creating one cycle with the other nodes, right? Like this. Okay, so if it is happening, right, it means there is only one outgoing edge of this node, right? Have in the edges, right? You can say it means it is in the cycle correctly. Okay, so if node cannot be a part of other cycle, right, because it only has one outgoing edge, correct? Means if we'll talk about this one, right, let me, what we have 3 4 2 we have, right? So if you'll take any of this node 3 4 or 2, right, so you can see that 3 has only one direction, that is in the 2, right? So we can say this node, right, this node is in the cycle, right, because it's simply only one outgoing edge of the node and that is in the cycle, right? So if we'll talk about this node, and this node any of either 3 4 and 2, this node cannot be a part of any other cycle, right, because it has only one outgoing edge, right, which is consumed in this cycle. Okay, so in this graph, right, we only say that only one outgoing edges we have, and node cannot be a part of any other cycle. I think you understand, right? So what we will do, we will visit all the nodes in the cycle right here, and if we started a graph traversal from any node in the cycle, so there is no point in revisiting the node in the cycle because they cannot be a part of any other cycle. You got it? So we can do the recursive calls, you can say, means we can revisit that node, right? So also there is also you can say no points in visiting the nodes that do not form a cycle again. Okay, and we have iterated over the only on outgoing edges if they have during the first visit. There is no point in the iterating over it again. So we can say visiting each node, right? Visiting each node only once is sufficient, right? So let's consider how, right? So if we have to calculate the length of any you can say cycle, right, any form of cycle, we will begin with a depth first search DFS, and we will start with the unvisited node, right? And we will iterate over the outgoing edges, go to the neighbor, from the neighbor to its neighbor, right, and so on to the last, right, from top to down, you can say, from all the nodes, right? We'll try to visit all the nodes. So during the traversal, right, what we will do, we will keep track of the distance from node 1, and we'll visit each node. So to store the distance, we can only use a hash map, right? And we'll put all that in there. Okay, so as a result, what we will do, we traverse the graph, right, and we'll understand, like, if we need to return the from node 2 to somewhere node 3, right? So there is a edge will take from the node 2 to 3 or 3 to 2, you can say, which already has been visited in the depth of search traversal. So if the denote, if it is there in the cycle, right, it will say, right, it will give some you can say exact number from the node to 2 to node to 3, and if we'll check into the you can say map, we'll do the minus, we'll get some value, right? So because we keep track of some distance, and from the starting node, right, we also add some value, right, on this node to complete the cycle, right? As a result, the cycle would be, you can say, have some value, we will put some +1, right? So it will bring us to our solution. We'll do that later. We'll try to understand this one. Okay, so let's go to the, you can say, browser, and we'll try to implement this one, because explaining is all about if you'll have some visual, right? So let's go to the browser, and we have given what we have given, edges we have given, and from the edges, what we will do, we will try to use that, right? And you can understand, if we have given edges, we'll consume its index as a node. I think you got it, right? So what we will do, we have this longest cycle edges, right? So I'll take we should find the number of node, right? So number of node is nothing but our n, and this is you can say we have given these edges, right? We have given what, these edges. So from the edges, we just only do what, edges dot length, and this is nothing but our number of nodes, and number of nodes is what, 0 to, you can say 0 to n minus 1. So these are our nodes we have in here, right? Now understand, like we will mark the visited node in somewhere. So to do that, what we have to do, we'll take you can say boolean, and this is nothing but our array, and we'll say visited nodes, and we'll have new boolean, and this is n will take. Okay, now what we'll do, we should take a map, and we'll store its you can say node and its edges, right? So to do that, we will visit from int I equal to starting 0, that is 0, from node 0 to its, you can say, last node, and that is I should be less than n minus 1. So we'll take n, and that is I plus plus. After this, what we will do, we'll check if not, right, this visited node we have. So if visited node doesn't contains you can say if the visited node doesn't contains this I, means we have not visited. So first of all, the node is not visited, then what we should do, we will write one we'll take one map, right? So on this map what we will do, we'll store two things. First we'll take we are trying to find its you can say we'll take my map. Let's suppose we'll take my map, and my map we will put our first we'll put our node, right? And we'll mark its distance as a 1. Okay, we'll bring the node. Now we'll do DFS utility, and we'll say we'll pass our node, then we will pass our you can say edges, right? And then we will pass our my map, right? And the visited, right? Visited nodes. So here what we have the purpose, we have the purpose to, you can say we will take some variable, right? And we'll try to return its answer. If let's suppose I'll create here one integer, and this is our you can say number of node, right? And if number of node will starting will take -1 if there is no cycle, number of node in cycle, number of node in cycle. Okay, so in starting we'll take number of node in cycle is -1. If we will have sub cycle, so we'll take the we'll count the node, right? And we will return, we will update, you can say, number of cycle in the node if have the cycle. If not, then after completing this node, right, what we should do, we will return here this node, right here. I think you have understood, right? So now what we will do, we'll create this DFS utility method, and to create this DFS utility method we have to create its body, right? So coming back to here, we'll take this as a void and we'll pass here. I will make the body here. This is nothing but our int node, and edges is nothing but our int, and this is a cycle, sorry, this is array. And what we will do, we will take a map, right? So I think I have already created this one map, this my map I'll pass here, and this is visited. So for the visited, this is a boolean type. I'll take this one, and all we have the definition now. Now first of all, if the node we have, if this node is not visited, means first of all we have to mark it as a true, means this is visited node now, and this is I is nothing but here its node. Okay, so first of all we have marked this node as a visited, and we'll try to find its neighbor. So we'll take int, and this is neighbor. For the neighbor I'll take any I, and it is nothing but our what we have at edges, and edges at we'll pass the node, we'll get our neighbor. And we'll try to find what if any I neighbor is not equal to what -1, and it is not you can say visited, right? So like this we can say, if visited node at what any I, means neighbor don't have -1 value, right? And it's don't have what it's not visited, means we have neighbor and it is not visited. In this case we have my map, right? So on the my map what we'll do, sorry, we will put this one, and we'll say now neighbor new node, we are not passing our node now, but now we are passing the node of our neighbor of our node, right? And that we have if currently we have some if our node we have, right? Let's suppose this is not coming first time, but we have already stored our neighbor, right? So if we have already stored our neighbor, so we will have some value there, right? So what we will do, we'll call there is a, you can say get method, right? And we'll check our node, means node is already there on the map. Now just we'll say we'll do +1, and will store here. Means we are updating neighbor, because we have now cycle, it is a direction, right? So from a node to, actually here what we are doing, we have, you can say direction, you can say we have a direction from node to neighbor node. This is the meaning, right? And so that if we will find this one, so now we'll update our my map and we'll say next node, we have the direction from the parent to child. Now never have a direction from what, the parent node, and we'll update each time, right? Now what we will do, if we have these things, means never have, we have update our neighbor, these things, right? So we have to just do our DFS utility for this node now. Okay, so I'll copy this line and we'll put here and we'll update our just NEI neighbor, right? We have what, we have our neighbor. So now node is nothing but our, in the DFS utility we'll pass neighbor. Now we have edge, now we have what, my map, and we'll pass our visited node. This is when we have not visited our neighbor. If neighbor we have already visited, let's suppose, means we should take one condition actually. In if we will we should pass was what we should pass, we'll pass if neighbor is what we have, we if neighbor not equal to, let's suppose not equal to -1 only, right? If neighbor doesn't have value, it's not equal to -1, and the visited, right? Rather than visited means we have you can say it's visited. What we'll do, we'll check onto the my map, right? So now we have my map. On the my map we should use contains key, right? Yeah, means this is the cycle. For the cycle we'll pass our node. So if this node is already, this neighbor node is already on the my map, means we are in the cycle, right? Already in cycle. If NEI not equal to -1 and it's already onto the map, then in this case what we will do, we'll say number of cycle is nothing but our we have to find the right maximum value, math dot max, and will pass number of cycle, and another will pass, we have my map, right? So on the my map, whatever, so from the my map we will get what you can say we'll do get, and we'll pass our node, and this node you can say we should do, this is parent node, and next what we'll do, we should call my map and dot get NEI actually, and we'll do +1. Okay, so this is, you can say, from parent node to its child node, and we'll do plus, right? So that if there is a cycle, we'll find our you can say all the nodes, right, between that all the node between that, and we'll do +1, and so that we will update our number of cycle, right? So in this way we will update our number of cycle, and you can say you will have your number of cycle updated now. Okay, so here what we are getting, you can say find all nodes in cycle. I think you have understood. Okay, so what I'll do, first I'll compile this one, yeah, and then I'll submit this one. Okay, this is working fine. So guys, let's understand one more time. Okay, so first of all, what we have to do, we have given number of cycle we have given, then what we have given, the number of cycle we have to take, right? And through the depth first from the DFS utility, we will update our you can say number of cycle, right? and finally that we will return this one. So to do that, right, what we will have to do, we have given edges. From the edges we'll get our nodes. We will take a visited node, so that we will update our visited node. We'll traverse from 0 to n minus 0 to n minus 1 node, and from here for the, if we talk about the time complexity, we'll take time complexity at O of what, n. Okay, time complexity only because we're visiting all the nodes, right? And if we are if this node is not visited, what we will do, we'll put onto this, we will put onto the map, and we will traverse on the DFS. And this DFS, first it will do what, it will mark this node as a true. We will get our never nodes, right? And we'll check if never is not equal to -1, means we have some never have some direction. And we can say if visited, if it is not been visited, we will put onto the, you can say, map, and we will update its value +1. And if direction have, then we will put onto the DFS again. And if it is never is not equal to -1, but it's already onto the map, means it is in the cycle, already in cycle, we will find our number of cycle now. So what we have to do, we will pass into, we will check the number of cycle max, and now you can say we'll do the minus from starting to node to its all never, and we'll do +1, so that we will find our number of cycles, and we'll have our number of cycle now. So finally, once this is done, recursive call is done, we will return our number of cycle. Now you can see we are taking a map, and each time we are updating our map, right? So for this one, what will happen, space complexity SC is also O of n. So for this program, time complexity and space complexity both will remain same. And thank you for watching. If you like this video and you want more videos like this, so please subscribe this channel, and please also share on this video on your LinkedIn, and you can say on Leetcode, so your friends will get updated this video. And thank you so much, guys.